What really caused the continental divide? Get your calculators ready and let's try and work it out. In this video, we're going to talk about pressure and in particular, how to calculate pressure. We have said that the pressure that an object applies on a surface depends on the size of the force that's being applied and the surface area over which the force acts. And we're going to investigate that in a little bit more detail. We use the formula pressure equals force over area or force over surface area. The pressure is measured in newtons per square meter, which can also be measured in pascals. The force is measured in newtons and the area must be in square meters before we put it into our formula. So now we're going to calculate pressure using our equation. But first of all, we're just going to consider it and think about two examples. So I've chosen Sid and Scrat from Ice Age, and we're going to think about the pressure that they exert on the ice when they dance and play with their acorn in Ice Age. So let's use the examples of Sid and Scrat and see who we think is going to break the ice. Sid with his big fat feet, or Scrat with his favorite little acorn. Let's look at their statistics. Sid's stats. He's got a mass of about 10 kgs and the surface area of those feet is probably about 0.01 square meters. Remember, we have to have the units in square meters if we want to use that formula. Let's look at Scrat's stats. Scrat, in fact, what Scrat's using to touch the ice is just that little acorn. So the mass of that acorn is maybe about 10 grams, so 0.01 kgs. And the surface area of the acorn tip, I've just kind of guessed, but maybe a millimeter by a millimeter. So if we convert that to square meters, about 100,000th of a square meter. Let's do some calculations now and work out whether it's Scrat and his acorn or Sid doing his Sid shuffle that is going to have an effect on the ice. So let's go ahead and calculate the pressure. We'll start with Scrat. Okay, and Scrat with his acorn. So we have the mass of the acorn there, 0.01 kgs, but of course the force that is being applied on the ice is due to the weight of that acorn. So first we need to work out the weight. Remembering our formula, weight equals mass times gravitational field strength, and we know that the field strength, the gravitational field strength on Earth is 10 newtons per kg. So we substitute our values into that equation, 0.01 kilograms times 10 newtons per kg, and we find the weight of that acorn is 0.1 newtons. Now we have the force applied by the acorn and we've got the surface area of the acorn. We can use our formula that we've learned, pressure equals force divided by area, to calculate the pressure. 0.1 newtons divided by 100,000th of a square meter. Use your calculators and you find that it is 100,000 newtons per square meter. Remember that 1 newton per square meter is equal to 1 pascal. So the pressure applied by that acorn on the ice is 100,000 pascals. Let's move over to Sid now and have a look at his statistics and use the formula again to calculate his weight. His mass is 10 kgs. So using the formula again, we substitute in 10 kgs times 10 newtons per kg, and we find out that Sid's weight is 100 newtons. Now we can substitute in that weight, the force is 100 newtons, into our formula, pressure equals force divided by area. Sid's weight is 100 newtons, and the surface area of his feet that are in contact with the ice is about 0.01 square meters. When we do the calculation, we find that the force, the pressure applied by Sid on the ice is 10,000 newtons per square meter, or 10,000 pascals. So Sid doing the shuffle is less likely to crack the ice than Scrat with his acorn. If we do another example of calculating pressure, this time we're going to use water balloons. And we can see similar water balloon about the same size, and we can see that in one instance the man is falling with his whole body weight on the balloon, and in the other instance a man is using a knife or maybe a screwdriver, just touching the balloon with the tip of it, or jamming the tip of it into the balloon, and the balloon bursts. So let's look at the information here. The water balloons are similar. Why does one burst when it's only touched and the other remains intact when the man jumps on it? So the knife tip, the force applied, and I have just estimated this is maybe 20 newtons, and the surface area of the tip of that knife is possibly about 0,000002 square meters. The man jumping, his weight is about 700 newtons. This time I've already done the calculations for you. I've turned his mass into weight, and the surface area of his body that has come into contact with the water balloon is probably about 0.2 square meters. Let's do the calculations. So if we calculate pressure using the formula pressure equals force divided by surface area, with a knife tip, the pressure applied is 20 newtons, the force divided by 200 thousandths of a square meter, and what we get is 10 million pascals, a really big force applied through a very small surface area, big enough to instantly burst that balloon. And for the second example, if we look at the man jumping on the water balloon and again calculate the pressure, we have pressure equals force divided by area. We've got 700 newtons is his weight, and his surface area is 0.2 square meters. And we work out that the pressure applied by him falling on that water balloon is about 3,500 pascals. So just a bit of fun with calculating pressure. Hopefully it has helped you learn how to use that equation. Pressure equals force divided by surface area.